today we are going to discuss chapter 14. The title of the chapter is Fluids. Have you ever heard this word fluids?
Yes, it's the water and
What is fluids? Could you please give me the answer?
It's like waters.
Like water
I
and
don't know the definition, but I have examples.
I don't know. I'm asking you the question. I'm not
Water,
asking you to
oil,
give
or
the definition.
something.
I'm asking what are fluids? What are fluids? Just give me the
Like
answer.
water, doctors. Waters, juice,
Only water?
Not each
juice.
other.
Only
Any
juice?
liquid,
Only water?
any liquid
Oil.
that take the
Any
shape.
liquid.
Everything that's related with the. I don't know how to say it.
Fluids can be
Everything that related
described
with?
as all liquids that take the shape of its container. That include
Only liquids?
not liquids, anything like it. Yes, yes. It can be solid. It can't be gases.
Brother, we have three matters. Am I right? Solid, liquid, and gas. Am I right?
Yes.
Yes, of course.
Out of these three matters, except solid, the liquid and gas are together called as fluids. So the gases as well as the liquids, whatever the gas you can take, whatever the liquid you can take, and all this comes under the category of fluids. So you should not include the solid here. Clear? So what are fluids? All fluids are gases and liquids. Clear?
Clear.
Yes.
Understand? Okay.
Yes.
Let's we just see the content. What topic we are going to discuss from this chapter? This chapter is very, very easy, but you have to read the question very carefully. All these questions comes from these chapters are a direct question. We will give the information, then you have to write the rule, you have to substitute the value in the rule, and you have to get the answer. That's it. So all questions are direct questions. So what are the topics today we are going to discuss here? We are going to discuss the topic what is density, because we already studied the rule for density in chapter number 1. Am I right? What is density, brother? Density rho, which is equal to? What is this?
M over V. It's the density.
What is M? Mass.
The
What is
mass,
V? Volume. We already
volume.
No, volume, not velocity. Volume, okay?
Yes, yes.
You
I
should not use
confused.
the velocity here. So okay, so we are going to study the concept of density. Why? Because the title of the chapter is fluids. Each and every liquid has its own density. Each and every gas has its own density. So we are going to study some information about that, means the basic definition for density, and then we are going to study the concept of pressure. Brother, in chapter number 12, we studied this rule. Am I right? The formula for stress. What is the formula for stress?
Like Bosch, force over area.
Area. Am I right? So
Yes,
the
you're
pressure
right.
also have the same. The pressure also have the same rule. So what is the formula for the pressure? The formula for the pressure is force per unit area. But what is the importance of this pressure? Here, the force you applied on the object should perpendicular to its surface in all direction. If you just apply force in one direction, it is not a pressure. So if you want to achieve this pressure concept, you have to apply the force in all direction. For example, you take a box or you take any container. So if you want to make the force here, what you have to do? You have to apply force in this direction. You have to apply force perpendicular to the surface, apply pressure force into the surface, force into the surface, into the surface, into the surface. So you can just see the picture. If you apply the force perpendicular to each and every surface, what will happen? Pressure will apply to this object. Am I right? So force per unit area is called as pressure. So what is the unit for pressure? Pascal or Newton per meter square. Clear?
Yes.
Okay. In this chapter, we are going to study two parts. What are the two parts? You can just see the slides. we are going to study the concept of Pascal's principle and Archimedes principle. I think some students, you already finished this experiment. Am I right? Archimedes principle, we already finished this experiment. Some students, you are going to do this experiment by
Yes.
this week, but some of the students, you already finished this experiment with by last week. Am I right? So in this chapter, we are going to study the concept of Pascal principle and Archimedes principle, and these two comes under the category of fluid at rest. So if any fluids at rest condition, and this principle is an example for rest condition. That means if any fluid at rest, then Pascal principle and Archimedes principle comes under this category. And then the second part of this chapter tells something about fluids at motion. If any fluids are under motion, then we are going to use this equation of continuity and Bernoulli's equation. So all these are in our day-to-day life application. In our day-to-day life application, we are just using this concept in our day-to-day life. So these are all the content today we are going to discuss. Brother, listen carefully. We are going to have one equation here. We are going to have one equation here. And likewise, we are going to have some equation here. We are going to use some principle here. So out of this four concepts, for sure, one question will be there. So please listen carefully. Understand?
Yes.
Understand? Okay.
Yes, Tigran.
Let's come for the introduction. It's an introduction to fluids. Could you please read the sentence line by line? You can just see I have 5 points here. Let's start with the first point. What is given in the first point? Physics of fluids is the basic of hydraulic engineers. That means if you are dealing with the mechanical, so this hydraulic concept will be there. That means the fluid dynamics. You have a topic fluid dynamics. Inshallah, in your engineering courses, you will study this concept. Have you ever heard this word?
Yes.
Yes.
So mechanical student, I think you have this topic in your engineering course. So physics of fluids is the basis of hydraulic engineering. And then second point, the fluid is a substance that can flow like water or air. That means it will conform to a container. Suppose if you take a water bottle, if you take a bottle, if you just fill this bottle, it will exactly accommodate in this bottle. Suppose if you take a cylindrical shape object, if you just fill this cylindrical shape object, your gas, your fluids will be exactly accommodated in this container. That's what it is clearly mentioned here. The fluid is a substance that can flow. So fluid can easily flow. It will be flow like water or air, and which will be exactly conformed to a container. And then third point, this occurs because fluids cannot sustain a shearing force. Brother, is it possible to apply the shearing force to the fluids? It's not possible. What is shearing force? Shearing force is the tangential force. We already studied. Is it possible to apply the surface force to the liquid or surface force to the gas? Is it possible?
We can't apply force
No,
to it,
doctor.
only through the container.
Brother, shearing force is nothing but, for example, I have water here. Okay. For example, I have water here. Is it possible to apply the tangential force to the surface to the water? Is it possible?
No.
No.
It's not possible because the water is a liquid. I'm right. It comes under the category of fluid. So tangential force is the force which will be exactly applicable only to the surface. So your shearing force, your tangential force is only applicable for the solid material. So shearing force or tangential force, it's only applicable for the solid material. But when you come for the fluid concept, shearing force is not applicable. That information is given in the third point. Let's come for last point, because the same concept, because this point is exactly related to your shearing force. So I already explained this point, and let's come for the last point. What is given in the last point? The essential identifier is that fluids do not have any crystalline structure. Is there any crystalline structure for the fluids? Solid material have the crystalline structure.
No.
But is there any liquid or gas have crystalline structure?
No.
It's not possible.
That's
So these are all the basic introduction for the fluid. Yes, brother. Yes, brother. I think someone they asked a question. Are you here? Okay. Let's we just start. Okay. Let's become for the first slide. What is given in the first slide? A liquid, a gas that can easily flow. So that means it can change its shape based on the container. Am I right? Suppose if you take a water bottle, the shape of the water or shape of the air is exactly the shape of the water bottle. Am I right?
Yes. Doctor, what
Yes.
flows
Am I right?
mean?
Yes.
What
Yes, my
flows
dear.
mean? What flows mean?
What?
What flows mean?
Just before I explain, what
Flows.
fluids or
Flows.
the liquids or gas? All liquids and gas comes under fluid. Fluids
No,
are the nature of liquid and
I mean say anything that flows. What mean?
anything
See.
that flows means to take a water bottle. My dear, first of all, listen me. First of all, listen my question. Take a water bottle, okay? Just open the cap. Just drop. What will happen?
It will spill out from the.
For example, this is water bottle. Just listen carefully. This is the water bottle. This water bottle is full of water. I just open the cap. I just drop in this direction. So what will happen?
Water go up.
Flow.
What will happen? The water will be flowing outside. Am I right?
Ah.
Yes.
Yes.
So that means it is easy to flow. Flow means it will be easy to flow. So whenever you just open, for example, if you take this bottle full of air, I just have this bottle full of air. I just tightly close this bottle. Once I just open this bottle, I have some gases. What will happen, brother? It will be easily going out. Am I right?
Yes.
So that is the meaning for it can easily flow. Flow means it has some direction to move. Clear?
Yes.
Clear.
Mr. Hassan, is it clear for
Yes.
you?
Yes.
Okay.
Yes.
Let's become for the concept of density. Brother, what is the definition for density? We already studied this rule many times. What is the definition for density? The definition for density is mass per unit volume. So everyone, we are just clearly know about this principle, and this formula is indicated with a Greek letter rho. So it should be pronounced with the letter rho. So rho, which is equal to mass over volume. The unit for this density is kilogram per meter cube. Brother, if you take any fluids, suppose if you take a water, if you take a petrol, if you take a honey, if you take any fluid, it has some own density. So the density of the water is 1000, the density of the salt water is more than water. So each and every object has its own density if it comes under the fluid. Understand?
Yes.
Okay. Let's become for pressure. Just before I told you, pressure is nothing but a normal force. What is the meaning for? Yes.
The gas. It's like it's including to fault or after brush. It's including to fault.
I couldn't understand what you are saying. Gas? What is that? Could you please repeat?
I mean the gas. It's like fault or not.
False or not means what is that meaning? You mean flow?
I will write it.
If you write it, I can't see, brother. Just a minute. I can see your message. What's your message?
I will write it.
Type your message, Mr. Abdullah. I'm just waiting for your message. Fluids like gas or after
Brush.
pressure.
Yeah.
Pressure.
Yeah. I mean,
What is the
could you please go to slide number 5? You mentioned here the float. No. After this, doctor. You mentioned here floats
This one?
are gas. No.
This one?
No. After this. Yes, here. Number B.
Okay.
No. Before this.
Yeah.
No. Before this. Before this slide. This here.
Okay.
Number B. You said a gas.
Yes.
This gas.
Okay.
It's after
Yes.
pressure. After brush or it's considered.
My dear, listen carefully. I have a container. Okay. I just take this container. In this container, I filled with gas. Okay. And likewise, I have another container. I just filled with water or any fluids, milk or whatever it may be, you can take. Okay. Now, when you just apply the pressure in all directions, what will happen?
Will be like water. Yeah.
It will be skewed. It will be skewed. Am I right? Its volume will be decreased. Am I right?
Yeah.
So likewise, when you just compress any gas molecules, what will happen? Its nature will be differ. So pressure, when you apply pressure, for example, in our day-to-day life, we have some examples. I will just give the examples after a few slides. By the time you will get a clear picture. Okay.
Okay.
By the time you will get a clear picture. Now we just see only the definition part. What is density?
Teacher.
Density is mass over volume. What is pressure? Yes.
The gas itself is fluid, like
Yes.
right or not?
Gas itself is a fluid. That's what it is. Yes, of course.
Okay. Okay, thank you.
Okay. Now let's come for the concept of pressure. What is pressure? Just to see the picture, I am just showing only one side. For example, what is the pressure? The pressure which is equal to normal force. What is the meaning for normal? Normal is the perpendicular force acting on the surface. For example, this is your surface. If you apply force perpendicular to the surface, that force is nothing but a normal force. So if you just consider this total surface and this surface has the area, so when you just apply the force perpendicular to the surface divided by its area, that will call as the pressure. Now at atmospheric pressure, if you just in the atmospheric level, what is the value of the atmospheric pressure? 1.01 multiplied by 10 to the power of 5 Pascal. So if you just go to the deepest ocean, what should be the pressure, brother? Just to see the pressure level. What is this pressure level? How many times it is increasing? This is our 1 atmospheric level. When you just go to the deepest ocean,
million.
110 million Pascal. That means if you are just going to the deepest level, what will happen? The pressure will be more. It will be squeezes you. Clear? So if you are in the atmospheric, for example, right now we are sitting in our home. You are sitting in a room. What is your atmospheric pressure? Your atmospheric pressure is nothing but 1 atm, and which is equal to 1.01 multiplied by 10 to the power of 5 Pascal. But when you are just going deeper level, when you are just going, if you are just digging the hole in the air, when you are just going deeper and deeper and deeper, what will happen? No one can go beyond few distance. After that, what will happen? No one can survive inside. It is not possible to dig a hole inside the earth for a long distance. It is not possible to enter that hole. Clear?
Yes.
Okay. Now, the unit for pressure is Pascal. Just before I told you, the unit for the pressure is Pascal or Newton per meter square, because we have the formula pressure which is equal to force per area. What is this pressure force? This force is the perpendicular force. So perpendicular force acting on the unit area, which is called as pressure. So its unit is Pascal. Let's come for how to calculate the pressure when related to the depth. Brother, listen carefully. It's very, very important. It's the very easiest calculation. So we have the formula for pressure as P, which is equal to F over A. Now what I am going to do? What is your F, brother? Your F is nothing but weight. Am I right? Your force is nothing but weight. Am I right?
Yes.
What, doctor?
What is the formula for force? Your formula for force is mass multiplied by gravity. Am I right?
Yes.
What is the formula for weight? Your weight is also mass multiplied by gravity. Am I right?
Okay. Yes, you're right.
So here my pressure, which is equal to force over area or weight over area, and in this W, what I am going to do, I am going to substitute mass multiplied by gravity divided by area. Now, what I did here, how we got this equation, brother? I'm just using the equation for the density. What is the formula for density? The density formula rho, which is equal to mass over volume. Am I right?
Yes, you're right.
Therefore, mass, which is equal to rho multiplied by its volume. Am I right?
Yes.
So in this place, how I can write rho volume gravity divided by area. Am I right?
Yes, you're right.
Okay, now what is volume? My volume is nothing but area multiplied by its height. Am I right?
Yes, you're right.
So in this, what I'm going to do, I'm going to substitute area multiplied by height. So then you will get this equation. Now what will happen? I can just cancel this area with area. So finally you will get the pressure equation in terms of density. So you have to consider the medium density and multiply by its gravity, multiply by total depth. For example, if you are just going to in the deeper level, so what should be the pressure? You can just use this formula to calculate its pressure. Understand? So pressure, which is equal to density rho multiplied by gravity multiplied by its total height. Clear?
Clear, doctor.
Clear.
Okay. Now, what is the relation connecting pressure and depth? I told you just before. When you are just going inside the air, when you are just digging a hole on the air, you are just entering in that hole. What will happen? What is the relation connecting pressure and the depth? So when you are just increasing, when you are just going more deeper and deeper and deeper, what will happen? Your pressure will increase. So here we have one example. You can see here, I have a container, and inside the container, I put a block. Understand? Clear, brother?
Yes.
Yes.
Clear.
Okay, this is my topper side of the container. I am going to say this is my Y1. My bottom layer of this material is Y2. Clear?
Clear.
Yes.
Okay. Based on the first layer, your force due to gravity will be here. Am I right?
Yes, you're right.
Likewise, based on your bottom layer, your normal force will be upward direction because we already studied. This is your upward force. This is your downward force. Am I right?
Yes, you're right.
So your downward force comes from the Y1 area, your upward force comes from Y2 area. That arrow marks tells you about the direction of the force. Now listen carefully. We are going to calculate the relation connecting the pressure and depth by using this equation. Now you can just have a look. Both how many? For example, you can see this picture. Picture 1, picture 2, picture 3. Brother, could you please tell me how many forces are upward direction? How many forces are downward direction?
2 force.
One upward and two downward.
That means my F1 is the downward force, my mg is the downward force, my F2 is the upward force. Am I right? So how I can write? I can write F2, which is equal to F1 plus mg. Am I right?
Yes, you're right.
Because my upward force, which is equal to downward force. So in this three picture, I have two downward force, one upward force. So my upward force is F2, my downward force is F1 and mg. Am I right?
Yes, you're right.
Okay, I write the same equation here. Now, what I'm going to do, we already know the formula for the pressure. What is the formula for the pressure? My formula for the pressure is force per area. Am I right?
Yes, you're right.
Therefore, my force, which is equal to pressure multiplied by area.
Yes.
Clear?
Clear.
So this is my F2 force. So my pressure is P2. Am I right? So this is my F2 force. So how I can write? I can write P2 multiplied by area. Am I right?
Yes, you're right.
Likewise, in this F1 force, I can write P1 multiplied by area. Am I right?
Yes.
Now, in this place of mass, because the object has the mass, so I have to use the rho formula, rho which is equal to mass multiplied by, so mass divided by volume. So therefore, my mass which is equal to rho multiplied by V. Am I right?
Yes, you're right.
So in this, what is my V? My V is nothing but area multiplied by its height. Am I right?
Yes.
So my height is nothing but y2 minus y1 based on this diagram. My height is, what is your height here?
Y2, Y1.
Y2 minus y1. Now what I am going to do, I am going to take this rule, I am going to substitute here. So take this, substitute here. So if you substitute here, you will get this relation. Am I right?
Yes, you're right.
So now we can see here, left hand side I have area, right hand side I have area. So everything will be cancelled out. Am I right?
Yes.
So what is remaining? I have P2, which is equal to P1 plus rho G multiplied by Y2 minus Y1. Am I right?
Yes.
So it is indirectly says my P2 is the normal P. You can just consider my P1 is the initial, and what is rho, and what is G, and what is Y2 minus Y1. My Y2 minus Y1 is the height. Brother, listen carefully. This P, which is equal to P naught plus rho multiplied by G multiplied by H, is nothing but Steven's law. Steven is the name of the person who find this equation, and this equation tells you the relation connecting pressure as well as the
Highest.
Deep.
what is this? Depth. That means here height tells you about depth. So here my absolute pressure is P, and this P naught is my atmospheric pressure. Now you can see here, brother, could you please compare this equation? This is my equation just before we found. Am I right? Now this equation, when you are just going deeper and deeper and deeper, this will be the relation connecting pressure with deep. Suppose if you are just flying in the sky, you are going into the highest altitude. That means you are just climbing some rock, some mountain. What will happen? What is the pressure? This is water. Okay, just listen carefully. This is the water. It has some height. Now a person is swimming here. Now a person is swimming here. Now what is the pressure here? The pressure here is this equation. Okay, understand?
Yes.
Now you have a mountain, big mountain, the highest mountain. Now a person is standing on the mountain. What should be the pressure in this region? This is your surface of the earth.
The atmospheric
What is the pressure here? What is the pressure here? Pressure inside. When you are just going deeper and deeper, your pressure has the value of positive because it is going towards the gravity. Am I right?
Yes.
Yes.
And when you are just climbing on the mountain, what will happen? You are just moving away from the gravity. So what should be your value of G?
Minus.
So when you are going to the highest level, that means in the upward direction, your pressure gets decreased too much. When you are just going deeper and deeper, your pressure will increase. Understand?
Understand. Doctors, be note.
Yes.
Could you please apply this?
My dear, listen carefully. How to find the absolute pressure? You can just consider two cases. One is, listen. First I will complete and then ask the question. Two conditions. One is going downward direction. Another one is going upward direction. Okay.
Yes.
Now this is the level. Am I right? This is the level. Am I right? My dear Abdullah, first of all, listen and then ask your question. Okay. First I will complete. I will answer your question. No problem. This is the surface of the earth. Okay. You consider this is the surface of the earth. Understand?
Yes.
What is the pressure here? The pressure on the surface of the earth is P naught. Understand?
Okay.
And when you just go deeper and deeper, what should be? You have P naught plus density of the medium. You have the gravity as well as how much deep you are going. Am I right?
Okay. Yes, you're right.
When you are going upward direction, you have atmospheric pressure plus minus rho G H. Am I right?
Yes, you're right.
Suppose you are exactly on the earth. Suppose you are exactly on the earth. What is the pressure here? What is the pressure? My absolute pressure, which is equal to my atmospheric pressure.
Yes, of course.
Clear? So when you are exactly on the surface of the earth, your absolute pressure, which is equal to atmospheric pressure. When you are just going deeper, your absolute pressure, which is equal to atmospheric pressure plus the density of the medium, gravity multiplied by height. When you are just going to the highest level, what is your absolute pressure? My absolute pressure, which is equal to atmospheric pressure minus density of the medium and its gravity multiplied by its height. Clear?
Clear. Yes, I got.
Okay,
Thank you.
that is the rule. This is the rule. No problem. It's my pleasure to help to explain. So this is Stevens law. So the name of the person who find this rule, the same rule. You can see here, whatever the things. What is our rule? P, which is equal to P naught plus rho G H. Am I right? What is rho here? Our rho is the density. So you can see here, my rho is the density. So liquid density. Clear?
Yes.
Clear?
Doctor.
Okay, brother, where we are using his application in our day-to-day life? Could you please read? Could you please just read this line? The pressure at a point in a liquid in static equilibrium. What is the meaning for static equilibrium? That means the liquid exactly in static condition. What is the meaning for static?
Standing still. It's not moving, not changing.
It will be rest. Am I right?
Yes.
Yes.
Okay, where is your water? Where is your liquid will be at rest? In our day-to-day life, we have many dams. Am I right?
What?
Have you ever heard the word dam?
No.
Yes, teacher.
I will show you the
The
picture.
wall that keep
I
water.
will show you the picture. I can just show you the picture, then you will get a clear idea. What is this, brother?
Yes.
Brother, listen carefully. Listen carefully. The construction of the dam is based on Stevens law. Because when all the doors will be closed, what will happen? Your liquid is at rest. Am I right?
Yes.
Yes.
You can see this picture. You can see this picture. Here, this is the wall, and this is our fluids. Am I right?
Yes.
Yes, you're right.
Now you can see here, this Stevens law is exactly applicable for the construction of the dam, because at the top your pressure will be different. When you are just going deeper and deeper inside, what will happen? Your pressure will be more. Am I right?
Yes, you're right.
Yeah.
So based on the construction of the dam is exactly based on the Stevens law. So at the top your pressure will be small. At the bottom your pressure will be a little bit more. At the bottom, if you are just going deeper and deeper, what will happen? Your pressure will be more. Then you have to construct the dam in a very perfect way. Otherwise, what will happen? The dam will broke. It will get damaged. Water will enter the city. Clear?
Clear.
Yes.
Clear?
Yes.
So this is an example. The principle of Stevens law is an example for fluids at rest. Clear?
Clear.
Okay. Now let's come for the first principle. So this is an example for the pressure at the fluid at rest. Pascal law. What Pascal law says, brother? Could you please read? Pressure at a point in a fluid is equal in all direction. For example, you can see the picture. I have two pistons. Piston 1 is here, piston 2 is here. Am I right?
Yes.
Yes, you're right.
Right or not? So the pressure what you applied here is exactly same in this area. Am I right?
Yes, you're right.
Have you ever seen this in your life? In our day-to-day life, we are having this. Am I right?
Yes, and
Yes.
This is the hydraulic lifting. When you are just go for washing your car, they will just make your car exactly in that tray, and they will turn on the switch, and it will be pressed. By the time, what will happen? When you just go and deeper, when you just see the construction of this hydraulic pumping, bottom they are using fluids here. Some hydraulic is based on oil, some hydraulic is based on gas. Clear?
Clear.
Yes.
And this will
So,
be
this will be, what is that?
Doctor,
Yes.
doctor,
Yes, Michael, please ask your question.
what happened when they push the button the left side? How would they go down? If they put
Brother,
weights
if you,
in the
brother,
left,
listen carefully. If you want to see the setup, then you have to. What? Could you please repeat again? I couldn't hear properly.
General, but I ask about the left side. What the change happen that makes it go down? Do you understand?
If you just
me?
come for the Pascal law, you must have two pistons. This piston will be connected with the electricity. Am I right?
Yes.
Am I right? So when you just turn on the button, what will happen? This piston will be pushing downward direction. Initially, both are in the equilibrium condition. So both will be in the equilibrium condition. When you just push, what will happen? This piston will be go down. Am I right?
How it push itself?
By means of some mechanism, electricity.
By the electricity.
Yeah. You can't press, brother, you can't press by your hand. It is not possible. You have to give high electricity.
Yes, yes. That's only that my
Okay.
question.
When you just push, what will happen? Here you have fluids. These yellow color are the fluids. So when you just push this piston, what will happen? This fluids will push the second tray, so your car will be lifted upward direction. Clear?
Yes. Yes.
clear.
Okay. Let's be
Doctor,
comfort, brother. Let's be comfort. Yes, yes.
it depends on the area, right, doctor? It should be bigger than the area
Of
one.
course, because yes, area is very, very important because the calculation of the area plays an important role here. Just listen carefully. Brother, could you please just see this part? Could you please see this part? So in this place, we are going to apply the force. Am I right? Perpendicular force. Am I right?
Yes, you're right. This is pressure.
So when you just give the perpendicular force, here pressure will acting. Am I right? What is the formula? Formula for pressure P1, which is equal to F1
Over A1.
over A1. Am I right? So you got this answer in this place. Am I right?
Yes, you're right.
So when you apply the pressure, the upward force will be acting on this area. Am I right?
Yes, you're right.
So in this area, what is your force? What is your pressure? My pressure 2, which is equal to F2 over A2. Am I right?
Yes, you're right.
So this formula is applicable for this area and this formula is applicable for this area. So now at equilibrium condition, what is the rule? The equilibrium condition, which is nothing but F1 A1, which is equal to F2 over A2. Clear? Which is equal to my pressure. So through this equation, you can find any one of the force. If you know the first force, if you know the area of the first cylinder, if you know the area of the second cylinder, you can know how much force is applicable on the second area. Am I right?
Yes, you're right.
So this is an equation for Pascal law. Brother, listen carefully. Why we are just saying this is a Pascal law? Because the fluid at rest here. Am I right? Initially the fluid at rest. The fluid is not flowing anywhere. Am I right or not? It is exactly accommodated in the container. Am I right or not?
Yes.
So this is the first rule for this chapter. So Pascal law means Please write this equation and please read the question. For sure, in your question, we will give any one of the force, either F1 or F2. And then we can just give the diameter of this piston. What is the shape of the diameter, brother? The cross section of the diameter is like an area of the circle. Am I right? Am I right or
Yes,
not?
you're right.
So if you just have the area of the circle, what is this?
So,
Radius. Am I right?
right.
Okay. If you consider this picture, I have the area like this size. What is this? This is my R2.
Radius.
This is my R1. So once you have the value of R1, once you have the value of R2, if you know any one of the force, you can easily find the another force. Am I right?
Right.
Yes, teacher.
So suppose in this equation, I am just going to find F2. What is my F2? My F2, could you please rearrange this equation? Could you please rearrange this equation? My F2, which is equal to F1 multiplied by A2
A2.
over A1. Am I right? Am I right?
Yes.
Yes.
Yes, yes.
And the cross section of the piston is like a area of the cylinder. What is the formula for area of the cylinder? Pi r square. Am I right?
Right.
So how you can write? You can write F1 pi r1 square over pi r2 square, which is equal to your F2. Clear?
Yes.
Except how it's possible.
So how it is possible means what you are asking.
About by R1.
No, this is R2 square. Am I right? This is R2 square. This is R1 square. Sorry.
Yeah, yeah. It's,
Now ask your
it's,
question.
how it's coming to by. We don't have shackle.
Brother, if you see the cross section of this piston, it's like the area of the circle. Take the piston and then see the overhead view. It seems like a circle structure. The piston will be exactly. There are different shape of the piston. Some pistons will be exactly square in shape. Some pistons are exactly in circle in shape. Some pistons are exactly in the rectangular shape. So it's depend upon the surface. Brother, in the question, if they give the radius, then you have to imagine the cross section of the piston is exactly the circle in shape. Clear?
Okay, clear.
Suppose if you have the rectangular shape, what is the use of R? Is it possible? If the rectangle have the radius, is it possible?
No, of course.
Because you have the radius only for the circle. Am I right or not?
Yes, you're right. Here in the
So in this question, I am just giving the value of R1 and R2. So immediately you have to guess in your mind, okay, the shape of the piston is exactly like an area of the circle. Just keep this point in your mind.
Here in the draw, the shape it's circle, right?
It's circle. Based on this question, it's exactly circle.
Okay.
Clear? Understand?
Clear, yes.
Okay. Now let's come for the Archimedes principle. Brother, we already finished this experiment last week. Inshallah, some students you are going to do this experiment by this week, and by the time you will get a clear idea. Brother, could you please read the slides? What is given? The buoyant force is the net upward force on the submerged object by the fluid in which it is submerged. For example, you can see here, I have a container and this container is full of water or any fluid materials. I just dropped a stone. I just dropped the stone. What will happen, brother? You can just see here, when you just drop the stone inside the water or inside any media, what will happen? Two forces will be creating. One is upward force, another one is downward force. Here, when any object inside the water, what is your upward force? Your upward force is called as buoyant force. Clear? You should not say it's a normal force. Understand?
Yes, teacher. Clear.
For example, I have a table. I just put one block of wood. Now, what is the upward force? What is the downward force? My upward force is the normal force. Am I right?
Normal. Yeah.
Yes.
No, and
What is the downward force? Empty. Am I right?
Gravity
Yes.
force.
Okay. Suppose I take the same material. I just put it inside the water. What will happen? Here also you have two forces. One is upward force, another one is downward force. Now in this situation, you should not say this is the normal force. What you have to say? You have to, this is a buoyant force. The buoyant force should be right like this. Clear?
Why,
Yes.
doctor? Because it's not possible to come normal force.
Brother, if you take any object inside the water, the upward force should not say like a normal force. You have to say that force is the buoyant force. If the object is outside of the water or any medium, you have to say that is the normal force.
What's the reason for this, doctor?
Normal reason means the scientists, they just find this information, because at least you have to differentiate these things. If some object in water, you have to give some different name. Am I right?
Yes, you're right.
Okay, my dear brother, I'm just jumping into the water. Listen carefully. I'm just jumping into the water. I don't know the swimming. I don't know swimming. What will happen, brother?
If G will be increasing, will be.
No. I'm not. Listen. My dear, listen carefully. I'm not asking the question in physics point of view. For example, you can, my dear Abdullah, listen first and then answer.
Okay.
Suppose you consider me, okay? I don't know swimming. I'm just jumping into the water. What will happen, brother? 1 or 2 or 3 times I will just come upward direction, and then only I will go to the deep. Am I right?
Yes, you're right.
Because I don't know swimming, initially 3 times I will come. Am I right? First time I will try to come upward direction, because the weight, based on your weight of the body, the water will give some upward force. That force is nothing but the buoyant force.
Okay. I got it.
Based on the density of the water. That's very, very important. That's very, very important. So in this place, you should not use your normal force.
Okay.
You have to say this is the buoyant force. Clear?
Clear.
Okay, so let's just read what is given in the second point. This force opposes the weight of the object. It comes from increase in pressure with depth. You can just see here, we clearly mentioned. So your buoyant force is coming from based on the pressure with depth. So based on the pressure in the depth area, your buoyant force will be acting. And that buoyant force is exactly opposing the weight of the object. Clear?
Clear.
Okay. Now we know this information. We already know your buoyant force is nothing but the mass multiplied by gravity. So if you take any object inside the water, for example, I'm going to take a stone. So this is my buoyant force. This is my force due to gravity. So I have tried mass of the floating body multiplied by gravity, and this is my force due to buoyant. So I can just write like this. Am I right? Here F tells you something about the floating object. If any object is in floating the water, then you have to say mass of the floating body multiplied by gravity. So we are just writing the same thing. Clear?
Yes.
Just have a look of this picture. What do you understand from this picture? Brother, I think those who finished the Archimedes principle, do you remember that you are finding the mass? You are finding the mass of the object in water. You are finding the mass of the object in liquid. Am I right?
Yes.
Yes, you're right.
Yes.
Okay, just to see this picture, here I just find the weight. So when you are just hanging the object here, because this is in air, so how much force is needed?
29.4.
29.4. Okay, I'm just taking the same object, I'm just measuring the weight. Now what is the value, brother?
19.6. It's decreasing.
So here you can see here, I have 29.4 in this direction. So same 29.9 will be in this direction. Am I right?
Yes, you're right.
Yes.
Now here you can see here I have 29.4, but in this scale I have only 19.6 Newton. So what is remaining? Remaining 9.8 is left. Am I right? When you just add this 9.8 with this 19.6, you will get to 29.4. Am I right?
Yes, you're right.
So what is your buoyant force? My buoyant force is 9.8. My scale gives 19.6, but my weight in the water is exactly based due to the gravity. I have 29.4. Now you can just calculate. You can just add these two, which is equal to this one. Am I right?
Yes, you're right.
Yes.
So when you take any force inside the water, the buoyant force will have some value. So that is the meaning here. For example, you can take an example of the ship. The ship is exactly sailing on the sea. Am I right? So by the time it will displace some amount of water, by the time the buoyant force will be acting on the ship, it will be pushing the ship in the upward direction. Otherwise, what will happen to the ship?
To sink.
Doctors,
And the designing of the ship is the second. Yes.
when we put something in on the water,
Yes.
the force due to gravity will be decreased, right? Will be not, right?
Will be equal to the upward force. Gravity force must be there.
It must be there, huh? It's not
Yes,
gone.
it must be there. Without gravity, how the object will exactly coming down? It will be coming down. Am I right?
Yes. Yeah. Yes, you're right. But this
Okay.
will be subtract
Now-
with the net force, with the
Yes, right.
buoyant force.
Yes, we have to subtract.
Yeah. Okay.
Clear? Okay. So now we finished two examples for the fluid at rest. What are the two principles we studied? We studied Pascal law as well as Archimedes principle. Am I right?
Yes, you're right.
So these two are an example for fluid at rest. Now we come for fluid at motion. So the fluid at motion, we are going to study the equation of the continuity. So here we have tried fluid at motion. So now what I am going to do, listen carefully, brother. Here I am just writing only the equation. I am going to give the example. I have this type of tube. So here my area is more. Am I right? In this place, my area is more. Am I right?
Yes, you're right.
Am I right or not? In this place, my area is small. Am I right?
Yes, you're right.
So water is coming. For example, you can take any liquid or any fluids, gas or whatever it may be. So you can just consider what is coming in this direction. Or I'm going to take an example of water. So if you just pass the water through this tube, what will happen? It will crosses this area. Am I right?
Yes, you're right.
Yes.
And then it will be crosses this much of area. Am I right? The second part. This is your first part. This is your second part. So initially, when the water will be coming in this direction, it will cross the area 2, and then it will be cross the area 1. Am I right?
Yes, you're right.
Now I'm going to calculate how much of fluid is flowing through this area. How much of fluid is flowing through this area? So I can just write the fluid flow in terms of Q. So I can just write Q2. The Q2 is the fluid flow. So what is fluid flow? My fluid flow, which is nothing but how much volume entering through this area. Am I right? Am I right or not?
Yes.
My dear, listen carefully. My dear, listen
Yes,
carefully.
teacher.
You can consider this is my area, okay? And this is my area. Now what we are going to do? We are going to study it. If any fluid is flowing through this pipe, the amount of water entering through this area must be equal to the amount of water entering through this area. Okay?
Yes, of course, because
Clear?
the pressure it's same.
Okay. First I am going to find the fluid flow in area 2. So how I can write? I can just write my fluid flow as Q2. Okay?
Yes. Okay.
Clear? So what is my fluid flow? My fluid flow is nothing but how much volume will be entering this area, capital V. Clear? Don't get confused about this capital V and small v. Small v is the velocity, capital V is the volume. Understand?
Okay. Understood.
Okay, now listen carefully. So my fluid flow in section 2, which is equal to volume of water in section 2 divided by how much time it will be take. Am I right?
Yes, you're right.
Likewise, right hand side of this equation, that means section 1, my fluid flow in this area, which is equal to volume in this area divided by time. Am I right?
Yes, you are right. What mean,
Alright.
doctor? This?
Okay, let's
What did you say? It's equal
this
to
Q
what?
is fluid flow, which is
Okay.
equal to volume divided by time.
Yes, you're right.
How much time it's needed to cross this area? How much time is needed to cross this area?
Clear.
Volume, I can write the volume. I can write the volume in terms of A2 multiplied by its length. Am I right?
Yes, you're right.
Divided
From
by
where we got
its time.
L2?
Am I
L2,
right?
from where we got it?
Brother, the formula for volume. What is formula for volume? Volume is nothing but area multiplied by its length. Am I right?
Yes.
Yeah,
My
yes,
dear,
you're
what
right.
is the formula for volume? My formula for volume is length multiplied by length multiplied by length. Am I right? So here my
Yes,
length multiplied by length is nothing but my area. Am I right?
yes,
So I can write the volume in terms of A2 multiplied by L2 divided by T. Am I right or not?
yes, you're right.
Likewise, I can write the same formula in the right hand side. So Q1, which is equal to A1 L1 divided by T. Am I right? Am I right or
Yes.
not?
Yes, doctors.
Okay, Q2, I can just modify this equation. I can write this equation like this. Am I right? A2 multiplied by L2 over T. I can write like this. Am I right? Am I right or not?
Yes,
Yes.
yes, doctor.
So likewise, this side Q1, which is equal to A1 multiplied by L1 over T. Clear? Now, brother, what is the formula for speed, brother? What is the formula for speed? My speed is equal to distance over time. Am I right?
Yes,
Yes.
you're right.
What is my distance? Here my distance is L. Am I right?
Yes,
Yes.
So in this place, I can write Q2, which is equal to A2 multiplied by V2, small v2. Here V2, small v2 tells you the velocity. Don't get confused about the capital V. What is this V2? This V2 is
velocity.
Volume.
velocity. So likewise, Q1, which is equal to A1 multiplied by V1. Am I right or not?
Yes, you're right.
Yes.
Suppose if I take the incompressible fluid, brother, have you ever heard about the word compressible fluid and incompressible fluid? Have you ever heard the word compressible and incompressible?
No.
Yes, I heard this, but
No.
I don't remember what is it.
Yes, we hear it. It's like equal to.
Brother, if you take a listen, if you take a compressible fluid, its density will be changing time by time. For example, in this place the density will be different. In this place the density will be different. Okay.
Didn't
Okay.
understand.
My dear, compressible means if any water, any liquid is flowing through this tube, if you take the compressible fluid, for example, you can take an oil or you can take any dense material. If you just pass these materials through this tube, what will happen? The density will be changing from point to point. Its density will be changing from point to point. So if you take the compressible fluid in this tube, this condition will not be satisfied. If you take compressible fluid, this condition will not be satisfied. If you take incompressible fluid, the density in each and every point of this tube will be same. So here I taken water. Water is an example for incompressible fluid. So incompressible means its density will not change at any point. Clear?
Clear.
So if you want to use the compressible fluid, what is the condition? If you are using the compressible fluid, what is the condition? My condition is Q1, which is equal to Q2. If you are using the compressible fluid, Q1 is not equal to Q2. So keep this information in your mind. Okay. So this equation of the continuity, if you want to achieve the Q1 which is equal to Q2, then you have to consider the incompressible fluid. If you are taking compressible fluid, Q1 is not equal to Q2. Clear? So okay, here I'm using which fluid I'm using? Which fluid I'm using?
Incompressible.
Incompressible fluid I'm using. What is an example for incompressible fluid? The good example is
Water.
water. What is a
Water.
good example for
We can
incompressible
consider
fluid?
here just water,
Water.
doctors. No gas.
No, you can use, but there are different types of gas, brother. There are different types of gas. We are talking about fluids. Fluid means any type of liquid, any type of gases. But here, when you just come for the liquid, you have two types of fluid, two types of liquid: compressible liquid, incompressible liquid. So water comes under the category of incompressible liquid. Clear?
Okay, clear.
Okay. Now you can see here Q1 which is equal to Q2. Therefore, my A2 V2 which is equal to A1 V1. Am I right?
Yes, you are right.
Am I right or
Yes.
not?
Yes.
Now in this place also I'm using the water. So water density will be the same. So left hand side and the right hand side my density will be same. So what will be your final equation? A2V2 which is equal to A1V1. What is A2? Area on the left hand side. That means area in section 2. What is V2? Velocity in section 2 which is equal to area in section 1 multiplied by velocity in section 1. Clear?
Yes.
Yes.
So please don't forget this equation. This equation is very, very important. What is the cross section? Suppose if we just give the diameter of this, suppose if we give the diameter of this section, so you have to consider the area is circle.
Yes,
Clear?
clear.
Okay.
Clear.
Let's we come for the last topic of this chapter. Let's we come for the last topic of the chapter. This is Bernoulli's equation. In our day-to-day life, we are just using this principle in our day-to-day life. Brother, you can see here, I'm just showing you the pipe of different width. Am I right? You can see here my width is different, here it is different, here it is different. Am I right? Am I right or not?
Yes. Yes.
Yes, you are right.
Consider this is a building. Consider this is a building. Okay, this is my ground floor. This is my ground floor area. This is my first floor area. This is my second floor area. So this is my ground floor. This is my first floor. This is my second floor. Keep this information in your mind. Okay.
Okay.
Yes. Okay.
Understand? Okay. Now let's we come for this size. Let's we come for the second floor. Brother, if you just see this pipe structure, it is little bit bigger in size. Am I right?
Yes.
Yes.
Okay. So when you are just going to the higher level, your pressure will be different. Am I right?
Of course.
Right.
This is your ground level, brother. This is your ground level. Just consider this is your ground level. When you just go to this side, your pressure will be different. Am I right?
Yes.
So in this place, what is my pressure? I can just take P1. Clear?
Yes.
Clear.
Okay. What is the height from the ground floor? This is my height. Am I right?
Yes, you are right.
Am I right or not? So what is my height? I can take Y1. So we already studied relation connecting pressure with respect to height. What is the formula for pressure? We studied this rule. rho G H. Do you remember this equation?
Yes, we remember.
So in this place, my pressure in terms of height is this one. Am I right?
Yes, you're right.
Okay. Suppose water is flowing. The water is flowing like this. In this place, the water has the kinetic energy. Am I right?
Yes, of course.
What is the formula for kinetic energy? Half
Half
v
V.
square. Am I right? This is
Yeah.
the formula for kinetic energy. Am I right?
Yes, you're right.
But we cannot be able to take for the water mass. So if you take water, we have to consider in place of mass, you have to consider its density. So how you can write? I can write half rho v square. Am I right?
Yes, you're right.
So what are the three parameters you need at some certain height? In this floor, I have pressure. I have the pressure with respect to height. I have the kinetic energy of the water. Am I right? Kinetic energy of the fluid. Am I right or not?
Yes, you're right.
Okay, let's come for the first floor. What is the pressure here? P2. Am I right?
Yes.
What is the height from the ground floor? This is Y2. Am I right? So I can use this equation. So rho G Y2. Am I right?
Yes, you're right. And the kinetic energy.
And in this place, the water has the kinetic energy half rho V2 square. Clear?
Yes, clear. Wow.
Let's come for the ground floor. So this is my ground floor area. So my pressure in this area is P3 and the height is Y3. So how I can write? Rho G Y3, and in this place also the water has the kinetic energy half rho V3 squared. So what you understand from this diagram, it is an equation which relates pressure of the fluid with height and velocity. So if any fluid is flowing, what will happen? It must have pressure. At the same time, with respect to the height, its pressure will change. With respect to the height, its velocity will change. Am I right?
Yes, you're right.
So this equation tells you the pressure of the fluid in terms of height and velocity. So please, brother, read the question. For sure, one question must be in this chapter, whether it may be equation of the continuity, or it may be the Bernoulli's equation, or it may be a Pascal equation, or it may be Archimedes principle. So out of these four, for sure, one question will be there. But you have to consider, if you take any pipe to certain height, you have to consider what should be the pressure in that area, what should be the height in that area, and what should be the velocity in that area. Once you just know these three parameters, solving the question will be very easy. But for this chapter, we have one question for each and every principle. We have one question for Pascal, we have one question for Archimedes principle, we have one question for Bernoulli's equation, we have one question for equation of continuity. Clear? So when we just solve the problem, by the time you will get a clear picture. But please don't forget the equation. Suppose if I have one more tube, what you have to do? Suppose I have one more tube. What you have to do? This is my Y4, am I right?
Yes.
This is my pressure 4. So how I can write? Which is equal to P4 plus rho G Y4 plus half rho V4 square. Likewise, if you just have 5 cube or 6 cube, you can just extend this equation up to that level.
Doctor, this pressure will not gain after we applied more pressures, more.
The given information will be, listen. The pressure in that area will be given. Don't worry.
Yeah, I know that, but I mean, when we applied.
Okay, let's just explain this. You can just have a look and then we will just solve the problems later. Could you please read this question? Could you please read the question? I'm just going for only the second part of the question. This question is related with the Bernoulli's equation. What is given here? The water pipe having 2.5 centimeter diameter carries the water into the basement of the house. That means this is your basement. Am I right? Am I right or not?
Yes, teacher. Yes, teacher.
Yes, sir.
Okay. In the basement, what is your pressure? Your pressure is P0. Am I right? Because when you are in the ground floor, when you are exactly on the earth, what is your pressure?
0, of course,
Zero.
because we don't have
Atmospheric
height.
pressure. Because you are exactly on the surface of the earth. At the surface of the earth, you have only the atmospheric pressure. Am I right?
Yes, you're right.
Yes.
Okay, now just see this question. If the pipe tapers 1.2 centimeter and rise to the second floor, that means this pipe is little bit tapers and it will be rising to the second floor. Now what is the pressure here? Is it exactly P0? No, we don't know. It is exactly the value of the P dot. It will be different. Am I right or not?
Yes, you're right.
And its height is tapers. How much height it is extended? How much height it is extended? You can see the question.
1.2. Yes.
Yes, 1.2. It's. Am I right or not?
Yes, you're right. Doctors, I mean,
No. Tapers
I
means
mean,
it will be
doctor.
rising. I think its value. It is a the value of the tapers is nothing but the diameter. Actually, the diameter of the pipe is given as 1.2, but height. What is the height? 7.6. What is the height of the pipe from the basement? 7.6 meter. So you have to see the pipe is exactly in the basement, and then it is rising to 7.6 to the second floor. So that means your pipe will be seems like this. So in this place, how much height it is extended? 7.6 meter, and in this place we don't know what is the pressure. But what is the pressure here? What is the pressure here?
1.
1.01 multiplied by 10 to the power of 5 Pascal. Am I right or not?
Yes.
Yes, you're right.
So when you are about to solve the problem,
It's like
by the time,
conserved
yes,
pressure. It's like conserved, like energy or not.
my dear, pressure will not be conserved. Pressure will be conserved only in the ground floor.
Ah, okay.
When you are just going to highest point of view, our pressure will be changed.
Yeah, of course.
So, brother, I think chapter 14 theory is over. Inshallah, next class, I think Wednesday, we have one period and we are going to solve these 5 problems. It is my kind advice to each and every one. Please, before we come for the class, check the slides and please have a look of each and every question. Each and every question. What is given in the first question? What is given in the second question? Whether this question is related with Pascal rule, or whether the question is related with Archimedes rule, whether the question is related with the equation of the continuity. Just have a look, and then inshallah, please come for the class. So when I am going to explain the question, because this question is a little bit lengthier, I have to give more information. So please, before you come for the class, try to have a look of the slide and try to come with some questions. Okay?
Okay. Thank you, doctors.
Understand, my dear brother? I think only I am hearing only few voices. One is Abdullah voice, second one Mr. Hassan voice, and third one Mr. Bazam voice, and sometimes Muhammad will saying something. But apart from that, no one will open your mouth. I don't know what happened.
We are listening.
You're listening means at least you have to ask the question.
Yeah, but we understand.
Okay, if you understand, it's quite welcome. Inshallah, don't worry, brother. After 3 weeks, we will know your understanding. Once the final theory exam question paper will be given, we came to know how much you understand in the class. Inshallah.
Inshallah, we will study well.
Okay, my dear brother, listen carefully. Only 3 more weeks is left. Please prepare well for your final exam and please try to utilize your office hour. Understand? Try to utilize your discussion class. Solve the question. I told you already, we will never ask the question outside the syllabus, and we will ask the question only based on the problem what we discussed in the class. It's my kind advice for all the students. Don't go for more number of problems, because some students, they want to solve more questions. It's my advice in this situation, because you have only limited time. Try to solve the question which we solved in the class. That will be quite enough for getting good marks. Don't waste your time. Just go for that same method, same type of problem, and try to take a practice. Do you get my point?
Yes. We got it.
Understand?
Understand, Doctor.
Only two voices are saying understand. Remaining 24 students, keep quiet.
Yes, yes, yes. I understand. Yes.
At least open your mouth and say yes.
يلا قولوا ياس.
Okay. Okay, my dear brother, I told you two numbers. The number end with 783, the number end with 227. Please kindly contact me after the class. And please go and check your SIS and please check your marks. If there is any mistake in the SIS mark, please kindly contact me because I am your theory teacher. I can only edit the marks in the SIS. Do you get my point? Understand?
Yes, yes.
Yes, teacher.
And the last information, please go and finish your e-survey. This is very, very important. If you are not completing your e-survey, your final lab, the grade will not be displayed. So it's my advice for each and everyone. I think 24 students you are here. Please go and finish. It will take more than 5 or 7 minutes. I think that's it. You can just read the question, give the answer. I think you know the link. Am I right? They already give the link. They already gave the link for you. Am I right?
Yes.
So finish the survey very quickly, okay?
Okay.
Once you enter the survey, finish for all the courses. For example, if you have 5 courses, means finish the survey for 5 courses. If you have the lab classes, do your survey. If you have theory classes, do your survey. So if you just take your schedule, how many courses you have, how many hours you have, finish the survey for each and every course. Whether it is theory or lab, you have to do it for everyone, so each and everything, okay?
Inshallah, we will teach.
Inshallah, inshallah, brother. This will be the last week. This will be the last experiment for this week. That means you already you are going to finish your physics 1 experiment for this semester. Inshallah, we will give some classes for revision lab. Those who are absent for some experiments, listen carefully. Those who are absent for the experiment, kindly do the experiment. Try to get some mark. We will never give full mark. At least we will give some mark for that experiment. Do you get my point? If you have any valid excuse, we will consider. Suppose if you don't have any excuse, suppose if you are absent, you can do that experiment. Try to get some mark.
Experiment
Understand?
number 9 or number 8?
You mean for this week?
10.
No, I mean
Number
not the previous one. The previous.
This week, listen carefully, brother. This week you are going to do either 9th experiment or 10th experiment. Okay. Inshallah, next
yes.
week when you come for the revision lab, by the time, if you missed any experiments, do that experiment, work out, get the marks from your teacher.
Doctor,
Okay.
experiment number 1,
Yes.
we don't do it. We didn't do it.
No, don't worry, that will not include it
Experiment.
for you. So for you only 9 experiments. For other students, 10 experiments.
Okay.
So those who have the classes on Wednesday and Thursday, you have only 9 experiments. Those who have classes from Sunday to Tuesday, you have 10 experiments. Keep this information in your mind.
Okay, thank you, Doctor.
Yes.
Okay, brother. So inshallah tomorrow or day after, I think tomorrow you have the office hour, am I right? The discussion class.
Yes.
Yes, from 7 to 8.
Yes.
Don't forget, if you have any doubts, please come and ask your question freely. Brother, first of all, try to talk with your teacher freely. Then only you will exactly get rid from your doubts. Otherwise, it is very, very hard. Okay. First of all, feel free to talk with your teacher. Understand?
Yes, Doctor.
Yes.
Because hardly speaks, you don't know my face completely. I don't know your face completely. In the lab classes, we are just seeing only the half of your faces. Am I right or not? Because everyone is wearing a mask.
Yes.
So please feel free to talk with your concerned teacher, not only for the physics course, for all the courses. If you have any doubts, please clear your doubts before you come for the exam. This is my advice for each and everyone. Understand?
Understand. Inshallah, today we will work hard and tomorrow we will ask you.
Inshallah, brother, it's my kind advice. Try to score more marks from chapter number 9 to 15. Once you score more marks, really you are in the safer side. It's my advice. When you are about to prepare for your final exam, please first of all show your concentration only from chapter number 9 to 15. And once you complete this chapter, just move to the previous chapter. Don't waste your time in the previous chapters. Clear?
Okay.
Okay. Yes. Thank you, teacher.
Yeah.
So first you work out from chapter number 9 to 15, and once you complete each and every problems in chapter number 9 to 15, just go and refer the previous chapter. Go and revise your previous chapter. I already gave the revision formula slides. Am I right? All the formulas are there. If any formula is missing in the slide, please include that. So that slide will help for the revision purpose. Okay?
Okay. Thank you, Doctor.
Okay, brother. See you, brother. Have a nice
See
day.
you, inshallah. Have a nice day.
Teacher.
Bye.
Have a nice day, Doctor.
Assalamu alaikum.
Wa alaikum assalam.